Hello students, this video session we are going to see what is a polynomial and how we can represent polynomials using linked list. That is what we are going to see in this session. Okay, last video session I think we had seen what is a sparse matrix and how do we implement sparse matrix using linked list. In today's session let us see what is a polynomial and how we can implement it using linked list, represent it using linked list. Now, first of all, let us see what is a polynomial. Now, in the school days, I think all of us would have learnt in mathematics something about polynomial. Is it not? A polynomial, let us call it as p of x. Okay, is the expression in variable x. So, it is going to be an expression in variable x, which is going to be of the form p of x is equal to a x to the power of n plus b x to the power of n minus 1 plus you go on like that up to let us say jx plus k. Okay, where this is how a polynomial is actually represented as. It takes the form ax to the power of n plus bx to the power of n minus 1 plus jx plus k. Okay, where all this a, b and so on, j, k, all this are nothing but some kind of real numbers. Alright, and then they are also called as, they are the real numbers, and n is a non-negative integer number or non-negative integer. This is called as, what is n called? N is always called as the degree of the polynomial. N is called as the degree of the polynomial. Alright, always every term, what is an essential characteristic of a polynomial? What is the essential characteristics of a polynomial? Every term in the polynomial expression, every term is ax to the power of n is one term, bx to the power of n minus 1 is one term, jx is also one term, k is also one term. So, every term in the polynomial should have two parts. Okay, it should have two parts. One is called as, which are the two parts? One is called as the coefficient, the other one is called as the exponent. These are the two parts. So, one is called as the coefficient part. Every term should have the coefficient part as well as the exponent part. Now, for example, let me take an example. 10x square plus 26x. This is a polynomial in x. Okay, p of x. So, what is the coefficient and what is the exponent here? 10 and 26. 10 and 26, they are nothing but the coefficient. This is 2. Here if nothing is there, we take it as 1. 2 and 1 are nothing but the exponent. Okay. So every polynomial term should have two terms, that is coefficient and exponent. Now, how do you represent a polynomial? This is what we have understood now about what is a polynomial. So polynomial is an expression of this particular form in any particular variable, where here in this case we have taken the variable as x. So every here a, b and so on, they are all some real numbers. N is the non-negative integer which is called as the degree of the polynomial. And every term of the polynomial will have two parts, the coefficient part and the exponent part. Now, having known about what is a polynomial, now let us move on to how we can represent a polynomial. Now, polynomials can be represented again in two different ways. There are two ways in which you can represent. One is the array representation. The other one is the linked list representation. Now, one is array represent. You can represent polynomial using array. You can represent polynomial using linked list. Let us go for linked list. We are for us linked list is important. So, let us see how we can represent a polynomial using linked list. Okay. Now, every node, I said every term of the polynomial will have two parts. One is the coefficient part, another one is the exponent part. These are the two parts of every term of the polynomial. So how can we represent it in the linked list? So let us see how we can represent polynomial using linked list. Okay. Something I will try to take like this. I will tell you what is this, each one is going to contain. Let me take a simple example of a polynomial. 4x3 plus 6x square plus 10x plus 6, whatever. So this is the example polynomial that I have taken. Alright, now I can take three fields in the linked list. Poly is the head which is going to point to the first node. Poly is similar to a head or start or whatever which is going to hold the address of the first node. Alright, now I am going to take three fields in every node of the linked list. The first node is going to hold the coefficient. The first field is going to hold the coefficient. The second field is going to hold the exponent. The third field is going to be the link to the next node. Okay, that is how we are going to represent polynomial. Every term of the polynomial should be there in the linked list, is it not? So first field I am taking as coefficient. Second I am storing the exponent. Third will be the link to the next node. So in that case, how can I store this particular the example that I have taken here, 4x cube plus 6x square plus 10x plus 6. How can I store this? So here coefficient first term is one node. Every term is one node. Okay. So first term, what is the coefficient? 4 is the coefficient. What is the exponent? 3 is the exponent. Now the third field is a link to the next node. So now what will happen? You have one more node here. Go to the second term. As I told, every term should be represented as a single node. Alright. So second term, we have coefficient is 6, exponent is 2, and then this is a link to the next node. Again the third node, what is the coefficient? 10, exponent is 1. Okay, x means x to the power of 1. Again you have link to the next node. Next what happens? You have only 6. Correct? 6 is nothing but is same as 6x to the power of 0. X to the power of 0 is nothing but, what to say, x to the power of 0 is 1. Okay, so in this case I will write 6, exponent is 0. You don't have any more nodes, so this will be nothing. This is how you try to represent the polynomial in a linked list. Okay, so this is your coefficient, this is the exponent or the power. And the third field is nothing but the link to the next field. This is how you try to represent. Alright. So now let us see one simple example of how do we add polynomials generally. Let us see that. Addition of polynomials. How do we add polynomials? You should add those terms whose exponents are equal. Yes or no? Right. So now let us take some example like this. 6x to the power of 5 plus 4x to the power of 4 plus 3x square plus 2 is one polynomial. Okay, I want to add this with 2x to the power of 4 plus 3x to the power of 3 plus 7x plus 10. These are the two polynomials I want to add. How do I add? How do I add this polynomial? First term is what? 6x to the power of 5. If I want to add this, there is no x to the power of 5 term in the second polynomial. This is my second polynomial. This is the first polynomial, second polynomial. In the second polynomial, we don't have x to the power of 5 term. Correct? So I will retain 6x to the power of 5 as it is. Then x to the power of 4 we have here also, So I can add these two terms. 4 plus 2 is 6, 6x to the power of 4. Then x cube I don't have in the first polynomial, I have it in the second, so I have to retain that. Okay, x square I have in the first polynomial, it is not there in the second polynomial, so I will write it as 3x square. Okay, next 7x is not there in the first polynomial, it is there in the second polynomial, so 7x. plus you have this last term is there in both the constants are both there in both the polynomial, so I can add that. So plus 12. So this is how you try to add the polynomial. You can have coefficients as either integers or you can even have it as floating point numbers. Correct. For example, if I say floating point number, I can have something like this: 1.5 x cube plus 2.4 x square plus 4x plus 3. This is also a polynomial. So this coefficient can be a floating point number. Alright. So now given this much introduction for polynomials and addition of polynomials, let us see how we can write a simple code for polynomial. Okay. Now, if I want to write simple code for polynomial, I will take a class poly linked list. So I will take it as poly_ln. Then I will try to declare something as private. I will try to take a node. So struct I will call it as polynode. In the struct I have one term called one field we want to have for coefficient. Correct. So I will take that as float. Okay, because as I told you now, coefficient can be integer or it can be float. So I can take that. Whereas exponent is always integer. So int exp. Then I will take a pointer variable we need, which is of the type polynode. So pointer link, I will call it as link. Okay. Then I will take a start pointer star p. Alright. Then let us say this is how I declare a node. Next, I have to declare some functions, member functions of this class. So probably I will declare maybe what can I say, poly append, wherein you are trying to append the okay, that's one function that I am trying to define. Poly append means we go on adding each terms. Polynomial can have several terms. Every term is a node. Okay, so I have to add the nodes and make it as one linked list. That's why I have taken this as poly append. One more function maybe I can take for display. And I can also try to take one function for addition of adding these two polynomials. Okay, these are the functions that I may consider. Let us see how we can append and display. Alright. So let's see how simple code how we can write. So this is a simple code for appending every term of the polynomial into a linked list. So void I have taken, this was a class that I defined poly_ln. Using scope resolution operator, I am calling this function poly append. I am passing these two as parameters, float c int e. C is the coefficient part and e is the exponent part of the power. Alright. Now polynode is a structure that we have already defined. I am taking one pointer star temp of the type polynomial, initializing it to p. P is our head or the start node or whatever. Now when I want to append a particular node, so let us say this is one term that I want to append. So this is my coefficient, this is the power of the exponent, this will be the link to the next node. Suppose I call it as 10. This is my new node that I want to insert. Let us say 4x square, 4x square is the term. So I will write 4 is the coefficient, exponential is 2. So then what I do? When I try to insert, if I am trying to check if the list is empty, obviously all this we have done so far, so I will go a little faster. If temp is equal to null, that means if the list is already empty, then temp is equal to new polynomial. Temp, I am creating a new memory for the new node, p is equal to temp. So this p is nothing but your start or head, whatever. So that will actually point to that temp itself will become the new node. Alright. So I will finish p is equal to temp. I will not go here. I will come here. Temp of coefficient is equal to c. So whatever value I have accepted from here, I am putting it at c. Temp of exp is e. So what value for power I am putting it here, temp of link is equal to null because it is the first node that we are trying to do. Alright. So if it is the list is empty, what are we doing? The new node itself is the first node, the first term that you are trying to append. If it is not empty, that means you already have some elements in the list or you already have some nodes in the list. Then what will happen? I want to append it in the end. Okay. So what we do, while temp of link is not equal to null. So this I have initialized p is equal to temp. So I will go on moving from here till I reach the last node. We have seen all this. So temp of link is equal to, we are creating memory for the new node. Temp is equal to temp of link. So the new node will be accepted and it is appended at the end. So temp of link is equal to null means the last node that you are trying to append, you will have that as the null value. Alright. So this is how we try to append every term of the polynomial as a single node. Every term. Suppose I say 3x cube plus 4x square, then this term is one node. This term is one node and we are appending it, making this entire thing as a linked list. So that you will have, so for 3x cube, it will come here like this. 3, exponent is 3 and your link will go to the next node like that. So the entire term we are trying to represent it, entire polynomial we are trying to represent it as a node. Next let us see how we can try to display the polynomial. Okay. So now let us see how we can display a polynomial. Now I have taken this as an example. This is the polynomial that I want to display. 4x cube plus 2x square plus 6x plus 3. How are we going to represent it? This is one term, 4, coefficient is 4, exponent is 3, link to the next node, a coefficient is 2, a power is 2, link to the next node, 6, power is 1, link to the next node, 3, there is no power here, 0, and link of the next node is, that node is going to be none because we don't have further terms. How to display this? Let us see. Now, I have declared class is poly-ln. We have defined this function already. So, I am taking temp as one of the pointer variable. I am initializing it to p. This is the p, the star which is pointing here. I am initializing temp to this one. Int f is equal to 0. I am just using f for some kind of counter purpose. So, while temp is not equal to null. So, if temp is it equal to null? It's not equal to null. Correct? So, if f is not equal to 0, then I am going to display all these things. But if in this case, for the first term to be displayed, f is going to be 0. Correct? So, it will come out of this. And then it will check if temp of exp is not equal to 0. Directly it will come here because we have not displayed even the first node. After we display the first node only, if you observe here, we are making f is equal to 1. What I am saying is, here f is 0. Correct? So, now while temp is not equal to null, temp is not null. Here this is temp. Then it will come into the while loop. If f is not equal to 0, f is 0, is it not? So, this condition is not satisfied, it will come out. It will come here. If temp of exp is not equal to 0, this is temp. What is temp of exp? It is 3. It is not equal to 0. So, it will display Cout temp of coefficient and temp of exp. So, I will display something like this, 4x to the power of 3. This is how I will display. Else, if it is not equal to 0, we have done this. So, we will not go into the else. Temp is equal to temp of link. So, this will now become our next temp. This will not be the temp. F is equal to 1. We are setting f is equal to 1. Again, we will come here. We will come into this while. Temp is not equal to null. So, temp is not null. If f is not equal to 0, f is not 0 now, f is 1. So, it will come here. If temp of coefficient is greater than 0, Cout plus. What is temp of coefficient? 2. It is greater than 0. So, I will display a plus. Else, I will leave it as it is because I don't have any more terms, that I have to take care of that. That is why I am writing that. Then again I will come here. If temp of exp is not equal to 0, it is not 0. So, I will display x to the power of 2. Temp is equal to temp of link. It will come here. Now, this will become our temp. F will remain 1. So, I will come here again. Temp is not null. F is not 0. Then temp of coefficient is what? 6. 6 is greater than 0, so I will display a plus. So after that, again I'll come here. Exponential is not 0. Exponential is not 0. Correct? So I will display 6x to the power of 1. Okay, temp is equal to temp of n. Now temp will come here. Last node. So what will happen? Again I will come here. Temp is not equal to null. F is not 0. Temp of coefficient is greater than 0. 3. 3 is greater than 0. So I will display a plus. Again I will come here. Temp of exp is now equal to 0. Correct? So I will not display this part. So I will come directly here because I can't write this because it is 0. No? So I will simply display Cout temp of coefficient. What is temp of coefficient? 3. That's all. Then temp is equal to temp of link. Again it will be pointing, but then what will happen here? Temp is null. So you will come out of the while loop. That's how you try to display a polynomial. How to add two polynomials? Also one function I have included in the code. I will share the code with you. You can go through that because that code is too long. And this program is not there in the lab cycle. But since you have it in syllabus, I thought you should also know. Theoretically, it is of no use. You should also know how we can implement it using polynomial. So I will share that notes on polynomials for you along with the program. So you can try that. Anyway, it's not in the lab, but still you can try in the lab. You can try execute the program. So with this, we are finishing the concept on the module on linked list. Next video session, I will be starting on trees. The next module, that is fourth module, I will be starting on trees. I'll see you all in the next session. Thank you.